Welcome to my classroom, grade 5s and parents. If you are a parent here, please gather all my grade 5s here because today we are going to discuss or to revise energy and change for NS Tech, which is Natural Science and Technology. Welcome to my classroom. I am Sir Rudolph Mathumbu. I am a professional teacher. I hold a degree in education and I am SAYS registered. If you need revision with all CAPS aligned subjects, you are in the right place. Please subscribe for more revisions. If you need private tutoring, please contact me using the contact details provided in the description of this video. Okay, let's get into today's lesson. So, straight to the first question. Question 1 says, match the input energy to the output energy. So we look at the input energy and we try to match it with the output energy. So here the instruction says color the matching pairs. So when they say color the matching pairs, it means you will have to use different colors. So if this, which is a fruit, you think it should be matched with this output energy, it means this and this will be colored with the same color. And if this matches with this one, you will color it with the same color. If this one matches with this, you will color it with a same color. So that is what this instruction is trying to tell us. So but I only have got the red pen with me. So what I will do, I will just use lines. I will draw a line from what I think from the output energy and to what I think it is the correct answer. All right, let's get to it. The first input energy here, I think it's a fruit. I don't know what kind of a fruit could it be, but I think this is a fruit. It could be an apple, it could be a pear, but it is a fruit. So this is an input energy, a fruit. When you eat a fruit, what kind of output energy do we expect? So when you eat a fruit, you get energy. And with energy, what do? Do you get hot? No. Do you get movement? Do you get light? Definitely no. Movement? Electricity? No. So when we look at this, what kind of output energy does a food or apples give you, or a fruit gives you? It is movement, because when you have got energy now, you can move and work, you can do a lot of things just because you have got energy. We move to the input energy number 2, and this is a matches. This is a matches, or it's a matchbox with matchsticks. It's a matchbox with matchsticks inside. So what kind of output energy does matches give it to you? Is it heat, movement, light, movement, or electricity? Simple. When you strike a match, you will get fire, and the fire will give off heat. So matches will give you heat. So the input energy of matches, you strike a match, you get output of heat. Okay, We move to the third one. The third one, this one, it is a battery. A battery. Okay, let's just move and we see all the options at least now here. What kind of output energy does a battery gives us? Does it give us heat? No. Does it give us movement? No. Does it give us light? No. Does it give us movement? I said no. Does it give us electricity? Yes. Batteries stores electricity in them. If you look at the batteries like the car batteries, cell phone batteries, you charge them, or you look at all rechargeable batteries, you recharge them. When you recharge them, it means you store electricity in them. So what kind of energy is a battery going to give you? Obviously it will give you electricity. Okay, let's move to the next one. This, when you look at it, you see a candle. It is a candle. So what kind of energy does a candle give you? The output energy. Is it heat? Okay, let's forget heat today. Is it movement? No. Light? Okay. Movement? No. Electricity? No. So which one is the correct one? It's light. We light candles so we get light. We don't light candles so that we get heat, but we use candles to light up our houses. So the output energy that we get from a candle is light. All right, we move on. The last one, when you look at this picture, you see it's a spring or springs. So what kind of energy does springs give you? Springs, remember, springs, if you press them, they push. If you pull them apart, they try to pull back. So what kind of energy does springs gives us? They give us simply movement. So springs causes movement. Okay, right. We move to the second question. The second question says, draw a diagram of the fire triangle and explain it. So the first instruction says you draw, and then afterward you're expected to explain. So what are you expected to draw? You're expected to draw a triangle. Okay, before we do a lot of things, let us just draw a triangle. This is a triangle. This is a triangle. So, but remember they said we should draw a fire triangle. A fire triangle is a triangle that shows us things that are needed for fire to exist. So it shows us three things that are needed for a fire to exist. So what is the first one? A fire to exist needs oxygen. If there is no oxygen, even if we can have fire, that fire will not live long. So the second thing that is needed is heat. If we had oxygen and we do not have heat, there could not be, we cannot have a fire there. So the third one, we need fuel. Fuel, what is fuel? Fuel is your wood, it's your paraffin, it's your coal, your gas, and many other things. So you need the fuel, you need oxygen, you need heat for fire to exist. So this is what it said when they say draw up a fire triangle. This is a fire triangle for you. So the second part of the triangle question said that you must explain. So the second part said you must explain it. Explain the triangle. All right. Oxygen from the air. The oxygen which is found from the air. So a fire gets oxygen from the air. So if there is no oxygen for that fire to burn, it means that fire will die or will go out. So we cannot have fire without oxygen. Okay, we spoke about heat as well. Imagine a cold fire. Imagine a fire where you take away the heat. Will that fire continue to burn? No, that fire will die. So for a fire to continue to burn, it needs heat. It needs the heat. So heat, it will burn the fuel. So if there is no heat to burn the fuel, then we cannot have fire. We can have wood, but if we don't have heat, those woods will just continue like that. We can have coal, but if we do not have heat, those coals will just remain like that. So the last one is fuel. Can you imagine a fire that only has heat and oxygen, but it does not have fuel? That fire cannot exist. So for a fire to exist, it should have oxygen, it should have heat, and have fuel. Fuel, as I have already alluded to in the first part of the question, it's your coal, it's your wood, it's your gas, and your paraffin as well. So these are your fuel. So we are done with the fire triangle. We go to question number 3. Question 3 says, mention 2 ways a fire can start. So they want 2 ways that can start fire. All right. 2 ways that a fire can start is number 1. A fire can start accidentally. And number 2, a fire can start naturally. Okay, first let's talk about the fire that got to start accidentally. This means that maybe by mistake you throw away a stick that has a burning end. A burning end. You find that you have got a stick, but the other end of the stick is still burning. You throw it away. Maybe it falls somewhere where there is grass, and the grass can be fuel as well. So you find that with oxygen and wind blowing on the stick. Now it catches fire. Now we have got a fire starting. So this fire was not intentionally started, but this fire was accidentally started. So the fire happened by accident. So the second one is naturally. Okay. Natural, it can be lightning. Naturally, lightning strikes a house and that house starts burning. So that is a fire that has been started. These are two ways that it can start a fire. All right, let's move to question number 4. Question number 4 says, how does one prevent fire from starting? How does one prevent fire from starting? Okay, here you can just think of examples that are your own. It means, first, you do not have to play with fire. You do not play with striking a match. You don't play with matches, because by so doing you might start fire. You don't light up candles and leave them like that. So you don't use electrical appliances and you leave them unattended. So you can choose one of the 4 that I have given you, and you will have answered this question. All right, we move to question number 5. Question 5 says, draw and label a simple diagram. So you are expected to draw and then label a simple diagram. A simple circuit. I mean, you draw and label a simple circuit. Remember, number 1, an electric circuit has to have a switch. So this is a switch of an electric circuit. Then these are wires. So you go down this side, and you can put a bulb here. So this is our bulb. Then you can put a battery this side. Remember that this sign represents a battery or a cell. So another wire continues this side. So now you can close up your circuit. So they said you draw and label. Now let's label it. This is a bulb, or some calls it a globe. So this is a switch. This is a switch, an open switch. So this is a cell. So this is a cell. It's not a battery, because a battery has got 2 or more cells. So these one that are running here are your wires. All right, now we have drawn our electric circuit and we have labeled it as well. 1, 2, 3, 4. We have labeled, we have got 4 components of the circuit. So now we move to question number 6. Question number 6 says that order the process of how electricity gets to our houses. So this means that you should show an order. What is that? Order. Order simply means that it's in sequence or they follow each other. How do they follow each other? It's like from one step to the second step to the third step. So they say put these words in order where you show how electricity gets to our homes or how electricity reaches our homes. Okay. Which one, when you look at these words here, you have got power stations, substations, coal, power line, pylons, electric box, and toaster. Then which one? Where does electricity start? I think electricity starts with coal. So coal is the first one. Coal is the first one. So they take coal to where? They take coal to the power stations, and that's where they heat the coal. So number 2 is power station. So this is the order. I am putting these words in order. The first one is coal. The second one is power station. So from power station, when electricity is generated from power stations, what takes electricity from the power station? It is pylon. So it means pylon will be number 3. So coal are taken to the power station and they burn them there, and then electricity is transmitted or transferred through pylons. So from pylons, where does it go? From pylons, it goes to a substation. So this will be number 4. Substation will be number 4. It goes to the substation where a substation will regenerate it and make it stronger. So from the substation, where does our electricity go? From the substation, electricity is transferred again using the power lines. So this will be our number 5. Power lines, we all know the power lines. We have seen them transmitting electricity. So from the substations, electricity goes to the power lines. And where does the power lines take the electricity to? It takes the electricity to the electric box. These are the electric boxes that are in our houses. So this means that it's our number 6. These are the electric boxes that are in our houses. So from these electric boxes, then it means here they have written a toaster. A toaster is an electric a appliance. It is an appliance. So it means now we can use the appliances, we can plug the appliances. So this will have to be our number 7. So by just doing this, we have ordered, we have shown the process in order. It starts with coal, and coal goes to the power station, and electricity from the power station is transmitted using the pylons. The pylons, they goes up until the substations. From the substations, now we have got the power line transmitting the electricity. From the power lines, it goes straight to the electric box. Electric box, now it goes to the appliances, your TV, your fridges, your stoves, and the other. So that's how we are expected to answer question number 6. So let's move to question number, okay, question number 6 has got a B there. I hope you see it. Question number 6 has a B. This was A, and this is B. Name the power utility that provides power for South Africa. The power utility that provides power for South Africa. And which utility is that one? It's none other than Eskom. Eskom is the provider of electricity in South Africa. So that's how simple that question is. Let's move to question 7. So question 7, when you look at it, you see hands of a human being here, and it shows a paper aeroplane leaving the hands there, and it continues until it falls on the other side. So the question says, explain the transfer of energy in this diagram. Explain the transfer of the energy. What kind of energy do we see here? What kind of an energy? The energy that they want us to talk about, it's an output energy. Then output energy. Which output energy is that one? It's movement. It's movement because from here it moves. This is an elastic band. The elastic band. So this is an elastic band, and this elastic band through this paper aeroplane, and it moves. So we see movement. So they say we should explain the transfer of the energy in this diagram. So this is how we explain it. When the rubber band, which is elastic band, when it is pulled, it's pulled back tightly, and then now the energy is stored in the rubber band. If it is pulled like this, now it has got energy. It has got energy. And then when the rubber band is now released, when it's now released, it it should be pulled together with the paper plane on it. So the paper plane should be here as well when you pull it. And when you release it, the rubber band transfer the energy to the plane, and the plane starts moving. And the plane starts moving. It come here, you pull the rubber band, you release it, the plane starts moving. So that's how the energy, which is movement, were transferred from the rubber band to the plane. So we move to number 8. Number 8 is a case study. So the instruction of this question says, read the following case study and give Letu advice. So you read and you give advice. Okay, let's read. Letu was home when a strong wind blew up and knocked a burning candle over. The candle fell onto the curtain, which set alight immediately. So it set alight immediately. Letu panicked and didn't know what to do. He didn't know what to do. So this case study, it's simply saying that Letu was home and there was a strong wind. The strong wind blew up and knocked a burning candle. So this was a burning candle over. It knocked it over, and the burning candle fell on the curtain. So the curtain was set alight immediately, and then Letu started panicking and he didn't know what to do. So now the instruction says, give Letu an advice. An advice on what? On how this could have been prevented and what he should do to stop the situation from getting worse. So the first, they speak about how he could have prevented it. And secondly, how can he stop it from becoming worse? So it means two questions or two set of questions or two side of the story that they're expecting you to look at. Number 1, the first advice that you should give Letu. Remember they say Letu started to panic and he didn't know what to do. And he could not know what to do because he was panicking. So the advice, number 1, that you should give Letu is to stay calm. So the first time is to stay calm. Try not to panic, because when you panic, you can make mistakes. But when you're calm, you can take good decisions. So that is the first advice that I will give Letu. The second one, the window should not be open near the candle, since the wind is blowing. So the window should not be open. Window should not be open near a candle, because now when you open a window and there is a curtain, now the curtain, because it has been blown by a window, it knocks over the candle, and the candle slips and start burning the curtain. So close the window. Close the window when you have your candle lit. That is the second advice. And the third one, at least move the candle to a place where it is safer. Somewhere where there is nothing that the candle can easily burn. Yeah. So it means here, even if there was a wind, it will not be able to knock the candle over and burn the curtain. So now let us look at how can you stop the situation. Number 1, I think he can just pour water to try and stop the fire. So pour water on the fire. That is one thing that he can try. Number 2, he can just use a fire extinguisher. He can just use a fire extinguisher. If it is a home where they have a fire extinguisher, he can just simply use it. Okay, let's move. We cannot see what is written there anymore. So another thing that he can do, he can just pull the curtain down. Now the curtain is burning, just pull it down. You just pull it down and try to stop the fire. And that is the last one. Thanks for watching this video up until this point. It shows that you are serious about your education. Remember, if you want to learn something, repetition is the mother of all learning. So it is very important that you keep on repeating this video until you grasp all the concepts that are explained here. If you feel that there are some things that I didn't cover in this video, please do not hesitate to put it in the comment section.